All right, we're going to try a big full-on review of factoring and see how that goes. So I've kind of divided this up into recognizing the type of factoring, how to do it, and then we're going to look at the answer together. So it's really important that you recognize what you're trying to do so you know the process involved. So this first question is a common factor question. I know that because there's a mishmash of terms, there's no real pattern to it, and I also know that I can divide all those numbers by 5. So we want to make sure that when we're common factoring, we divide by the greatest common factor. And the greatest common factor can be a number by itself, it may be a variable by itself, or it may be a combination, a number and a variable. In this case, I've decided to start with the most difficult one and do a number and a variable. So 15, 20, and 5 all divide by 5. And if I look at the variables, each piece, each term, each has at least an A and a B in it. And the way you get your common factor for the variable is you look at the variables of the lowest degree or the lowest exponent. And now I'm going to go back and I divide each piece. So 15 divided by 5 is 3. If I take an A out of A cubed, I have A squared. If I take a B out of B squared, I have a B. And then I do the next one. Minus 20 divided by 5 is 4. A squared, if I take out an A, leaves just an A. B cubed, if I take out a B, leaves B squared. And then the last one, 5 divided by 5 is 1. If I take out an A and I take out a B, they're gone. So I just have 1. Don't forget the 1. So if you divide something by itself, the answer is 1. So there's common factoring. Second type is factoring a simple or easy trinomial. So sometimes we call them simple trinomials as well. We recognize a simple trinomial because of its pattern. It has an x squared, an x, and a number. A simple trinomial will have nothing in front of the x squared other than 1. So it's just an x squared. So the way we factor those guys, if you remember, it's the opposite of FOIL. So it's the opposite of FOIL. I want to find what multiplies to get negative 20 and adds to get 8. So I play with my factors. I look at what multiplies to get negative 20. And so if I look at that, I have 1 and 20. I have 2 and 10. I have 4 and 5. And that's it. And I want to see what will add up to get 8. Because I'm multiplying to get a negative answer, one of the numbers is going to have to be negative. So looking at my 2 and 10, I know that if I did 10 take away 2, I would get 8. So my factors would be x minus 2 and x plus 10, because negative 2 times 10 is negative 20, and negative 2 plus 10 is 8. So if I were to do FOIL, I would go back to x squared plus 8x minus 20. So that's simple trinomials or easy trinomials. Difficult trinomials are named because of the fact they're difficult. What we are looking for in their equation that tells us they're difficult is a number in front of the x squared that does not divide out. So 11 and 9 do not divide by 2, so we're stuck with the 2. There are 2 ways I'm going to show you to factor a difficult trinomial. One is just guessing and checking and filling in your brackets and doing FOIL. The other is a more algebraic method called decomposition. So I'm going to do the guess and check method first. So I've got 2x squared, 11x plus 9, it's an x. And I know I need my 2 brackets to make a trinomial. So when I do the guess and check method, I look at what multiplies to get 2. So really just 1 and 2. And I look at what multiplies to get 9. So I've got 3 and 3, or 1 and 9. And I basically am playing around with the numbers so that when I add them together, I'm going to get negative 11. So I'll look at my brackets. I could have 1x times 2x to get 2x squared, and I could have 3 times 3 to get 9. And then I'll pretend like I'm doing FOIL. So I'll do x times x. There's my 2x squared. X times 3 is 3x. 3 times 2x is 6x. And 3 times 3 is 9. So right now they're all positives. And I want my answer in the middle to be negative 11. If I put my x's together right now, I'd get 9. So that's not going to work. Even if I changed my signs to negative, I'm still going to get negative 9. So I guessed some numbers and they don't work. So I'm going to try something else. The only thing left to try is to switch to 1 and 9 instead of 3 and 3 for the 9. So if I switch to 1 and 9, I'm just going to erase all that. That would mean I would have my x and my 2x, and then I would have 1 and 9. So now if I check in my head, I've got 2x squared, I've got 9x, I've got 2x, and I've got 9. So my ends are right. And hey, my middle is almost right. 9 plus 2 is positive 11x. But I want it to be negative 11x. So the only thing I have to do now is put a negative sign in there, and I should get the right answer. I'm going to double check. X times 2x is 2x squared. And x times minus 9 would make that minus 9. And minus 1 times 2 would make that minus 2. And a minus times a minus still makes that plus 9. So now when I collect my middle terms, I would get minus 11x, just like the question. This whole part I do in my head. I don't actually write it down like this on the question. I do it in my head or off to the side to check. So that now I know my factors are x minus 1 and 2x minus 9. If I want to do decomposition now, let's take a look at decomposition. Let's see how much space I got here. Oh, I got tons of space. So if I want to do decomposition, there's some steps involved with decomposition. The first step is multiply your first and last numbers together. So that means in this case, I would be doing 2 times 9. And I would get 18. And then I look at what it adds to. So I make note that the middle add up to negative 11. And then I want to find or determine numbers that add to negative 11 and multiply to 18. So I'm going to look at what multiplies to 18. So I've got 1 and 18, 3 and 6, and 2 and 9. And if I add up those numbers, well, that's not going to give me negative 11. If I add up those numbers, that's going to give me 9. That's not going to give me negative 11 either. If I add up those numbers, I get positive 11. And if I make them both negative, I would get negative 11. So I take these numbers now and I go back to my question. 2x squared minus 11x plus 9. And this is the decomposing part. So the decomposing part, I keep the beginning exactly the same and I keep the end exactly the same. But the middle gets decomposed or broken up into these two numbers I just figured out. So I would have minus 2x minus 9x. And it doesn't matter which one you put first. It'll work both ways. So after we get those numbers, whoops, we rewrite our equation, our function, and decompose the middle. Once we've done that, we take a look at our first two pieces and we common factor. So the first two have a common factor of 2x. So if I divide them both by 2x, that's what's left. And then I look at my last two pieces, watching the sign will stay with my factor, and I common factor. The common factor is 9, and it's negative because of the sign in front. So if I divide both by negative 9, I have x, and 9 divided by negative 9 is minus 1. So we've rewritten. Now we factor by grouping in twos. After we factor by grouping, we should notice that the two brackets we have are the same. If they're not the same, something's gone wrong because that bracket becomes our common factor. So one of our factors is x minus 1, and the other one comes from the two common factors. And so there's our factors, just like we did by guessing and checking. So we finish up by stating our two brackets. So decomposition, oops, I started writing decomposition. Decomposition seems complicated, but when you get good at it and you do it multiple times, it becomes really easy. So those are two ways to do difficult trinomials. And last but not least, difference of squares. So difference of squares, the phone's ringing in the background. I don't know if you guys can hear that or not, but anyway, I'm going to keep going. Difference of squares has its own little pattern. Difference of squares, oops, has this x squared, a minus sign, and this number is something that we call a perfect square. And if you're not sure what that is, then you should touch base with me. Difference of squares, you square root both terms in the and put the number in the brackets with opposite signs. Really easy, because if you were to do FOIL, I'll show you in a second. So I have an x at the front of each bracket, and the square root of 49 is 7. So I have plus 7 and minus 7 to get negative 49. And if I were to do my FOIL, I would get x times x is x squared, and I'd have x times minus 7 is minus 7, and 7 times x is 7, and minus 7 plus 7 makes 0 x's, and that's why there's no x term. All right, there's our big factoring review.